from signal system topic. We will solve problems from the another year of GATE exam. Problems in signals and systems. Okay. The first problem. This problem is a 1 mark problem, and this it is asked for a even function of time. The Fourier series will contain what? Okay, or Fourier series will not have something. Okay, for even function of time. Okay, Fourier series will not have. Choices were, first is DC term, second is cosine terms, third is sine terms, fourth is odd harmonics. Okay, now see, just to explain it in little details, we know a Fourier series, if I want to represent a signal xt, whether even or odd, any real value signal xt, then I can write in terms of Fourier series components a naught plus summation n tending to minus infinity to infinity an cos n omega naught t plus summation n tending to minus infinity to infinity bn sin n omega naught t. Okay, so this is a for any real signal. Okay, now if condition is given that signal xt is even, if it is even, that means the only terms present in the right hand side are the even terms. That means sine term will not be there. Okay, if it is xt is given as odd, then both cos term will not be there and a naught will also be not there. Okay, so if xt is even, then Fourier series will not have sine term. Okay, similarly, if xt is odd, then Fourier series will not have DC term and cosine term. Okay, so I think this problem is clear. So since it is containing only even function, it is an even function of time, so that's why it will not contain sine terms. Otherwise, both cos term as well as DC term will present. Okay. Question number 2. This question is regarding to find the inverse Laplace transform. Xs is given by s plus 5 upon s plus 1 s plus 3. Find xt. Okay. Now this is given as s plus 5 upon s plus 1 s plus 3. Use partial fraction. I can write this as 2 upon s plus 1 minus 1 upon s plus 3. So now finding the inverse Laplace transform is very easy. It will be 2 e to the power minus t minus e to the power minus 3t. This is the answer for this. Okay. Next question. In this question, it is again a 1 mark question. In this it is asked, for any energy signal, autocorrelation function will possess no symmetry, conjugate symmetry, odd symmetry and even symmetry. Okay. Right. Autocorrelation function will have odd symmetry, even symmetry, conjugate symmetry, fourth one is no symmetry. It is not symmetric. See, for any signal, autocorrelation function will always be even symmetric. Okay. So answer for this will be even symmetric. We need not to thought about the signal, just we have to see whether it is an autocorrelation function which is found. If it is found as autocorrelation function, that means symmetry is even symmetry. Next question. In next question, input is given and impulse response of a system is given. Okay. We need to find the filter output. Xt is given a e to the power minus alpha ut. That means this only for t greater than 0. Alpha value is greater than 0. Impulse response xt of a system is given as a e to the power minus alpha t. Ut is not mentioned in this, alpha t. We need to find yt, which is the output of the system when input is x. How to find that? Now, see, we have to find yt. So finding yt is easier once if we know that yt is nothing but it is a convolution of xt convolved with ht. Okay. And either we can find it out using convolution, or we can take the Laplace transform of xt and ht. Then my ys will be xs into hs. Okay. So there are two methods. Either of the method we can use to find the output yt. So suppose if I convert into Laplace transform and find my ys will be nothing but a upon s plus alpha plus a upon s plus alpha. So this will be a square upon s plus alpha whole square. Okay. And if I found, and then taking the inverse Laplace transform of this, yt will be a square t e to the power minus alpha t. Okay. Suppose if we take the convolution, yt is nothing but 0 to t e to the power minus alpha t minus tau e to the power minus alpha a square will be outside tau d tau. Okay. So if I integrate this, I'll get the a square t e to the power minus alpha t. Simple procedure. Either this method or this method. Results are going to come in. Okay. Understood? This problem is appeared in GATE 1996 exam. Okay. So whatever problem we are doing now, they appeared in GATE 1996 paper. Next question from the same year, 1996 paper. Question number 6. In this, a block diagram is given. I'll first draw the block diagram. The D represents the delay element. Here I am getting output by n and my input is x minus 2 and minus 3. For the given figure, I need to find the expression for yn and the transfer function yz upon both equal to question mark. I need to find both the things. Okay. Okay. For finding this, it is just like a flow diagram given. For this flow diagram, we have to find just like in a control system, we are using the flow diagram, signal flow graph. Same way we have to use here also. Okay. So first, if I write at this point, suppose this point is point P. So if I find a sum of all the things which is coming at point P, then I can write here, let that be x dash. X dash n is equal to xn plus 4 times of x of n minus 1 plus 5 times of x of n minus 3. Now I can write yn in terms of x dash n. Okay. So it will be x dash n plus minus 2 y of n minus 1 plus minus 3 y of n minus 2. So this x dash n will be yn plus 2 y of n minus 1 plus 3 y of n minus 2. Okay. So this x dash n are equal. So I can write here y of n plus 2 times y of n minus 1 plus 3 times y of n minus 2 is equal to xn plus 4 times of x of n minus 1 plus 5 times of x of n minus 1. Okay. Now, I got the relationship between yn and xn. Now, to find yz upon xz, I need to find the z transform of this expression. Let this expression be 1. Okay. So, to find the z transform of above expression, in terms of yz and xz, I can write here yz plus 2 times z minus 1 yz plus 3 times z minus 2 yz equal to xz plus 4 times of z minus 1 xz plus 5 times of z minus 3 xz. Okay. So I can take yz term common and take xz term common from the right hand side and can write this as 1 plus 4z minus plus 5z minus 3 upon 1 plus 2z minus plus 3z minus. Okay. So this is a solution and this is an expression for yz upon xz. This expression for yz upon xz is nothing but the transfer function of the given block diagram. Oh, so this block diagram represents a system. So this expression is nothing but transfer function of the system. Okay. We can see once again, given the block diagram, we need to find expression for yn and yz upon xz. Just assume one point P here. This point is same as this point because it's just a multiplication by 1. Okay. So I assume that that point P, the whatever is coming, that is equal to x dash n. So x dash n I have written. Similarly, I written y dash n, sorry, yn in terms of x dash n and yn. Then I can compute this equation 1a, this equation 2a. From 2a, I can get this equation. This equation, when I compute with the first one, 1a, I can write the expression for yn in terms of yn and x. Okay. Similarly, to find the z transform of in terms of yz and xz, so just the delay terms can be represented by z to the power minus 1. Two delay terms can be represented by z to the power minus 2. Similarly, the n delay terms can be represented by z to the power minus n. So writing that expression, I will get this expression. Okay. So this was one problem which has appeared in GATE 1996 exam. A similar type of question which has appeared in GATE 1997 paper, and this is the question number 7. A block diagram is given. Delay element is inserted between, and the first point where it is coming, this one is y1n. Again, there is one more delay element. Or this it is y2n. Okay. Now from here to here, there is one amplification factor by 2 coming from yn, and this is subtracted. Again, one more point which is coming from y2n. Here, amplification factor is 1. Okay. Assume for n lesser than 0, xn, y1n and y2n are 0. Okay. First question is find expression y1n and y2n in terms of x. This was the first question. Another question is also there. We'll see that afterwards. First we'll solve this one. Okay. So we'll solve first part. Just assume point P here. Okay. And let this point P equal to x dash n. So I can write expression for x dash n, which is equal to xn minus 2 times of y1n. This is also minus sign, so minus y2n. Okay. y2n is equal to y1 of n minus 1. Okay. And y1n is equal to x dash of n minus 1. So I can write my y1n is equal to x of n minus 1 minus 2 times of y1 of n minus 1 minus y2 of n minus 1. Again I can write this as, I can replace y2 by y1, x of n minus 1 minus 2 times of y1 of n minus 1 minus y1 of n minus 2. This one is y1. So this is a square expression for y1n in terms of xn and y1. Okay. Similarly, if I want to write expression for y2n, y2n is nothing but y1 of n minus 1. So replace this expression by this expression. I can write here x of n minus 2 minus 2 times y1 of n minus 2 minus y1 of n minus 3. This one is y2n. We can replace y1n n minus 2 and y1 n minus 3 by y2n. Okay. So this is a one solution for y1 and y2n. Now the second part of this question is to find y2z by xz. That means we have to find the z transform and take the and write in the form of rational, write it in a rational form. Okay. We have seen the expression for y2n. y2n is written as x of n minus 2 minus 2 times y1 of n minus 2 minus y1 of n minus 3. Now, but we know that y2n is equals to y1 of n minus 1. Okay. So y1 of n minus 2 is equal to y2 of n minus 1. y1 of n minus 3 is equal to y2 of n minus 2. To replace this in the above equation, I can write this as y2n is equal to x of n minus 2 minus 2 times y2 of n minus 1 minus y2 of n minus 2. Okay. So taking the terms on the left hand side, y2n plus 2 times y2 of n minus 1 plus y2 of n minus 2 is equal to x of n minus 2. Okay. With this, y2z upon x2z can be written as z minus 2 upon 1 plus 2z minus 1 plus z minus 2. Okay. Simple. This is the expression for y2z by x2. Taking the third part of the same question, we need to find y2n. Okay. If xn is equal to 1 for n equal to 0 and it equal to 0 at other points, other values of n. Then we need to find y2n. Now, solution. Y2z I already know it is equal to z minus 2 upon 1 plus 2z minus 1 plus z minus 2 into x2z. Okay. X2z given equal to 1 because, sorry, this is not x2z, xz, because xn is equal to 1 only for n equal to 0 and it is 0 elsewhere. Thus y2z is equal to z minus 2 upon 1 plus 2z minus 1 plus z minus 2. Okay. Now to find the inverse of y2n, inverse of y2z, I will get y2n is equal to n minus 1. Why? Because this expression I can write it as z minus 1, z minus 1 upon 1 plus z minus 1 whole square. Okay, so I'll get this term only by differentiating minus d by dz of some expression y to z. Okay, some expression y dash z, where y dash z is equal to 1 upon 1 plus z minus 1. Okay, on differentiating this I will get this. So z minus 1 is already, z minus 1 means delay by 1 unit. So I'll get n minus 1 as my y2n. So this was the problem which has appeared in GATE 1997. Another problem which has appeared in GATE 1998. A periodic signal xt with period t0 is given by xt is equal to 1 for mod t lesser than t1 and it is 0 for t1 lesser than mod t lesser than t0 by 2. Okay. Now for this I have to find the DC component in xt. Okay. Solution. To find the DC component, which is nothing but equal to a0 value in Fourier series. Okay. Now I can find, if I would plot this xt, it is something like this: minus t1 to plus t1 this is t0 by 2 minus t0 by 2. Okay. Amplitude is 1. So to find the DC value, I need to integrate from minus t0 by 2 to t0 by 2 1 dt upon 1 by t0. But the problem here is the range minus t0 by 2 to plus t0 by 2, it is not required for all. Okay, because this is one only between minus t1 to plus t1. So I can write here 1 by t0 minus t1 to plus T1 1 dot Tt. So this value will be 1 by T naught T minus T1 2 plus T1 is equal to 2 T1 upon T naught. Okay, so this is the solution of this problem.